Hello, everyone. Welcome. We are just starting shortly. Just give us a bit. We'll have substantial people joining in, and I'll begin with the introduction. Thank you, everyone, for joining. Hi and welcome, everyone, to our webinar LLMs in Fraud Detection Model Comparisons. Uh, I'm very excited to present this topic today because Akmal is a great expert in this particular topic. And my name is Yukti Divedi. I'll be your moderator today. One of my main jobs at SingleStore is to organize weekly AI webinars. We actually organize 2 or 3 webinars per week, and we demonstrate data and AI use cases along with new tools and technologies. So if you guys want to learn more, I actually post about upcoming webinars every week. So if these topics are interesting to you, please feel free to connect with me on LinkedIn to stay in on the top of the loop. Also, I would like to hear your feedback or ideas, any suggestions on the topics that you would like to see in the future sessions, or any feedback regarding this webinar if you guys have any questions. So coming to future sessions, we have amazing webinars that are lined up for the next weeks. On May 29th, as you can see on your screen, we have Supercharge Your MySQL Apps 100x at scale, no code changes. So this is a event, like a webinar come event that is getting hosted by the India team that is on, I think it's at 2 p.m. IST. So for the Indian audience, please feel free to tune in. I know it's like at a little late hour for us. And coming forward on June 3rd, we have open source Copilot for personalized banking applications. Please feel free to join in if this topic is interesting. On June 5th, we have building full stack AI apps with Vercel, Next.js, and GPT-4o. Very interesting for the people, those who want to learn more about OpenAI's new spring release and like how it compares with different models. So looking forward to see you all there, and please RSVP right now. Also on this slide, you might notice that we also have a auto RSVP to our future AI webinars option on our website available now. So if any of these topics of any on these landing pages is interesting, there's now a checkbox to actually auto register, which will add these future sessions to your Zoom automatically. And you guys don't need to join each webinar live, but it's actually an option for those who have requested to automatically receive any video recordings or any GitHub links, which might be useful for any one of you. Great for students, great for people, those who want to stay in the loop of everything that's new in AI and tech, because our team is definitely coming with up with new content every month, every week. Joining us today is Akmal Chaudhary. He's one of the best webinar speakers we have at SingleStore, and he's an expert in database technology space, and is definitely a very known, recognized subject matter expert in the same domain. He focuses on big data, data science, and NoSQL. It's really a privilege to have you, Akmal, and please, I would like to hand it over to you now, and thank you.
Great. Well, thank you very much, Yukti. My cheeks are going red, I think, with that introduction you've done for me. You're too kind. Thank you very much. Okay, well, thank you all very much for joining. So it's just gone a little after 6 p.m. my time here in London. And so, good morning, good afternoon, good evening from wherever you are joining in the world. We know your time is valuable, and therefore, hopefully, we will make this worth your while, that you attend, gain some knowledge, gain some insights. It's an opportunity for us to share what we've learned with you, and we will take your questions as well, and hopefully be able to assist you in that respect. Okay, so if you have attended the fraud detect, oh, that's wonderful. My Google speaker is going off thinking that I am asking the questions. I may well switch that off if that happens again, if he interrupts again. Anyway, I was just going to say that if you've attended the previous webinar that I've done on fraud detection, which was, I think we labeled it as GPT Workshop, we did one earlier this year, and the original one was done a year ago, roughly, when essentially, ChatGPT really started to take off, and we saw a lot of interest around that area. We thought we'd like to, investigate it, take a look at it, see how the technology stacks up against some traditional techniques. And in that time, we found that comparing it against scikit-learn versus Apache Spark versus OpenAI for kind of fraud detection, and this was credit card data, okay, which is easily accessible. It's on Kaggle, And I'll show you the link for that in just a moment. But that essentially, not only the first time, but the second time, the LLM didn't really perform very well. And it's essentially, I think the reason was that I was trying to bend the technology to try to solve a problem, which I think it really wasn't designed to do. Okay, I mean, it's great for chatting, it's great for text analysis, it's great for giving you information, much less good at doing some analysis of, say, transactional data or credit card data or things like that. And therefore, for this particular webinar, what I wanted to do was to give it a bit more fair sort of chance, a bit more of an even playing field. Try to utilize an LLM for this problem, but taking it from a different perspective. Okay, I will look at that momentarily. So in terms of agenda then, so a little bit of an introduction. We'll say very briefly some of the AI and ML integrations that SingleStore has. Now, I'm going to focus on financial fraud, okay? But you can extend that easily. I mean, as you know, fraud has many different guises and faces and occurs in many different industries. And therefore, you can apply the same general principles here as well. So although with financial fraud specifically, I mean, the data set we are looking at is very much focused around that. Again, Yukti will post the various links to that. Now, she did mention that she will share the, I think, the GitHub links in the chat, and you can follow along with me. I wouldn't recommend that, okay? Simply because you're going to be too slow. Again, you'll see why in a few minutes' time, but you'll have the links. You'll be able to do this in your own time and just, take it and don't have to work through everything in one go. All right, so demos we'll get to, as I said before. So, excuse me. Let's just start with this thing here, okay? So the link that Yukti will share with you, if you click on that and you want to be entered into the draw, this is the page that you'll get to. So as she mentioned, the free tier, okay, currently in preview, or you can run the dedicated tier. I am going to use the dedicated today, and I'd recommend you do the same as well, simply because the CSV file that I'm going to upload, I'm going to use a technology called Stage, which is in preview as well, which it can accept anything up to about 5 gigabytes in size. I mean, that's a lot. The CSV file that I've got is about 220, maybe 30, something like that, I think, in terms of size, which is more than enough for what we need to do today. And then you'll see again in terms of loading that in and then storing that in SingleStore. We'll get to that momentarily. So signing up is super simple. So I'd highly recommend you do that to be entered for the draw. Okay. For those of you that just attended a couple of days ago when we were looking at running Olama locally, and I mentioned some of the issues around that in terms of privacy and security, having control of your own environment, running things behind the firewall within your own environment. It's very interestingly, just within the last day or so, I came across this, and I'm not connected with this in any way, but someone has actually built an LLM firewall. There you go. All right, so this is design a beautiful sort of animation there. So, you've got a retrieval firewall, prompt firewall, and response firewall there. So obviously someone's noticed that there's an opportunity to do this, and kudos to them, well done. And you can see that now you can actually have a firewall that will help you in this regard. I haven't taken a detailed look at the technology, so I cannot comment on that. But just to mention to you that now you may well see more of this being offered in the very near future. Okay, so let's move on to back to the slide deck. Okay, so let's take a look then. So briefly then, again, sorry for those of you who've seen these two slides before. It's just a quick intro to the company. So basically what this shows is that we have been around for some time, okay, since 2011. And then during that period of time, the revenue has grown substantially. Excuse me. $100 million US dollars in ARR now, and over 350 customers, global customers. And down at the bottom there, you can see some of the investors that we have, well-known names. Okay, you may recognize some of these names and brands. And some of these are actually our customers as well. Okay, so not only do they invest in us, but they actually use our technology as well. Very briefly then, in terms of the product itself, well, it is capable of handling both OLTP and OLAP, okay, through this concept of universal storage. Originally, the product and the company used to be called MemSQL, okay? You may have heard of us focusing purely on in-memory and OLTP. Subsequently added support for analytics, columnar storage, and so it's fairly unique in the industry. So I think we are still waiting for other people to catch up. We've had this capability for a little while now. Works very well with a lot of other technologies, such as Kafka, and we've demoed these in the past, Spark. And if you are using some, in quotes, kind of legacy systems, HDFS, Hadoop, well, we can ingest from those as well as S3. So I think the animation here is demonstrating this concept of parallel ingest using this pipelines, as they're called. So you can read in vast quantities of data at scale. We are on the 3 major cloud providers in the Western world, okay? And today I am going to be using AWS. So we do work on Google Cloud and Microsoft Azure. You can run us on-prem as well if you wish. And there's a Docker container as well. But I'd highly recommend just using the web interface. Basically, it makes your lives easier because there's nothing to install. That is really, really helpful. For someone like me who has to constantly build demos and install and uninstall software, having this cloud-based environment or virtual machine is a godsend, because it means that the stability of my laptop is important to me in terms of my work, and therefore being able to run things, as long as you've got an internet connection, you've got a browser, you can do stuff, and that's just awesome. The stored data types, well, relational, naturally. We've demonstrated geospatial in the past as well, time series, full text search, okay, through the Lucene full text search engine. JSON support has been there for some time, even better with SingleStore Chi for MongoDB. And of course, vectors, okay? Everybody's favorite technology today. Lots of vendors are offering vector support. If you were sharp-eyed and you saw in the previous slide, right in the middle of it, around about 2017, we actually offered vectors. And that was as a result of, I think it was a financial customer that actually asked for that support. Earlier this year, it's got better. Okay, so there is a dedicated vector type, support for ANN indexing, lots of cool stuff as well. It's all documented, okay? So I'd highly recommend you have a look at the documentation and give you lots of information on that. And then briefly, just to round it out in terms of some of the areas that you could use it, in terms of applications, real-time analytics. And today we're very much focused around this area of machine learning. Dashboards as well. So your favorite technology, Tableau or whatever you like to use. I like Metabase simply because the free version, just download it. It's just a single jar file. As long as you've got Java, you can fire it up and be creating pie charts and doing some analytics in a matter of minutes. Okay, there we go. Very quickly then, so SingleStore can happily work with a wide range of technologies. If you want to do machine learning and AI, this is not exhaustive, just some examples. And in the recent past, we've shown support for, Apache Spark and MLib. We're going to be using Python today. Vector functions, out of the box, we support Euclidean distance and dot product. Cosine similarity is very easy to code. And if you've got something else that you want to use, you can use this code engine using WebAssembly. So essentially, if there's some algorithm or some way that you want to measure distance, if you can code it up, you can package it up, you can upload it into the database engine. It runs in a separate space, okay? So if there's a bug in your code, it doesn't bring everything crashing down, but now the database engine can treat that as a UDF, and you can utilize that over your data. Very cool feature, and we've talked about it in the past. And of course, working with LLMs. In the past, I've done a lot of OpenAI. The sad fact there is that you have to pay money for that, okay? So today, I'm going to give you a little bit of a break. So all the stuff you see is going to be free, okay? So you're not going to have to pay anything. And moving forward, I think we'll try and include that in as many of these webinars that we do, so it makes your lives easier. You don't have to get an API key. You don't have to pay any money to anybody. We'll try to make that as easy as possible for you in terms of your ability to replicate what we show you. All right. So one slide on Gen AI in banking, and essentially, I think, let me just get rid of these Zoom controls here. So this is a report from McKinsey, okay? So the economic potential of generative AI, the next productivity frontier. So huge potential in the banking and financial services industry. And I'm sure, again, if you look at that table there on the right-hand side, you'll see that total percent of industry revenue, and then lots of areas that it might potentially have some impact. And many of us, I'm sure, have experienced some of these things on the right-hand side here. Customer operations and support, marketing, software engineering, risk and legal, particularly if you work in this industry yourself. So basically, lots of opportunities there. Financial fraud detection. Okay, get your magnifying glass out and fix your eyes on this. Sorry about that. What I wanted to do, and by the way, there's a TLDR for this, okay, on the next slide. So I will summarize that for you. But what I was interested to see was, what are the kind of three principal ways that we could deal with fraud detection? Certainly, there are traditional techniques that have been around and used for some time. I know that very well because I've been a victim of fraud, and sometimes I get calls from my bank just to verify that a transaction that I've initiated is really me, or is it somebody trying to pretend to be me, and perhaps they've gained access to some financial data. And then we've got some machine learning techniques that, sort of the classic approach, if you like. And that's tried and tested. There are companies out there, and this is documented as well, who are actually using machine learning techniques to help with this sort of fraud problem, which is pretty extensive these days. And then finally, we have the potential that large language models might offer. Now, the thing is that in this particular chart here, this information here is well known, basically because we've got plenty of experience with this. This is also pretty well known in the sense that a lot of these techniques, tools, and technologies have been around for a while. They are well known, well understood. People can apply them and have done so successfully. So there's good sort of experience there. At the moment, this area is a bit of a unknown in the sense that what I've listed here is the potential. I've yet to see significant realization of this, right? That's, if you like, that's my assessment of it. But that's not to say we may not benefit from this going forward. And so I think, keep your eyes open, go in and evaluate this technology with the realization that it may not necessarily be the right fit for you. I think there is a tendency whenever something new comes out, we all think that it's awesome, it's going to solve all our problems, and then we want it to solve all our problems. And the reality is that at some point in time, the dust settles, we kind of realize that, okay, it can help with a problem or a set of problems, maybe not everything, or maybe we need to utilize it in conjunction with something else to actually get the maximum benefits. And I think currently that's what my thinking is, that the large language models are great for certain problems. Certainly there is potential to help with fraud detection, but I think we're not there yet. And I think until the technology improves significantly and we see some real examples of how it's been applied in the real world, I'm still a little bit doubtful as to whether by itself it's going to work. So here's my kind of TLDR. So just to summarize, so the traditional approach, great, because we've got predefined rules, statistical analysis, manual reviews. It requires some human intervention. It's effective, for known fraud patterns, but not very adaptable and scalable. High false positives and slower response times. Okay, you've got to wait for somebody to look at it and then be able, I have to wait for someone to call me from the bank, for example. With the machine learning, learn from data, detecting new and unknown fraud patterns, much better, okay? It's much more adaptable, good accuracy, it scales well in real-time responses once you've built these models. And then over time, of course, as new data arrive, they can learn from that and improve. And the downside, though, is you do need people who understand this technology. It requires data science expertise. Moderate implementation costs. Okay, so there is some cost. Okay, because not everybody may have those skills. You may need to hire people or look at the appropriate tools and technologies to assist you with that. And then with the LLM there, advanced natural language processing, contextual analysis to detect fraud patterns, potential. I think that's what the potential is. Highly adaptive and scalable with real-time capabilities. Well, for the existing applications and the RAG-based stuff that we are using it for, absolutely. I mean, it works really well there. But requires significant expertise, high initial costs. But the potential is, again, over the long term, lower ongoing maintenance and potential for advanced fraud detection. So, I've kind of given it the benefit of the doubt there. And really, my wish is that it is successful. That's what I'm thinking, okay? But I've yet to see significant moves in that direction. Okay, now let's get to the demos then. And let's talk about some of this code. So what I wanted to do then was to look at how we could evaluate it, okay? And so let me just show you something here. So this is the data set that I found, okay? So it's on Kaggle. So this gentleman here, Amit, worked on this problem. He shared this financial statement fraud data. So he very kindly cleaned this all up, uploaded it to Kaggle, okay? And so the zip file is 48 megabytes, unpacked the CSV is a couple of hundred megabytes. And so what he did was he took these financial statements that companies have to make, and I think this is to the US Securities and Exchange Commission, SEC. So if you read this, okay, and I'll just mention it briefly, I'll leave it to you to investigate this in your own time, okay? And don't worry, well, there's a link and to his work, plus the notebooks. We'll share that with you momentarily, okay? So it's 85 companies involved in fraudulent cases and an equal number of companies not involved in fraudulent activities, okay? So it's a very small data set, 170. So that's the basis of this. And so it consists of just two columns. You've got a lot of text in one, okay? That's the actual financial filing. And then the second column simply contains a yes or no. Is it fraudulent or not? Okay, Y or N, a binary sort of classification there. And so in this situation, essentially, if we take a look, well, certainly something like logistic regression is a good sort of choice as sort of the base. And it's something easy to implement, okay? Because it's just giving you two choices, is it fraudulent or not, right? Simple. Something a bit more specific is this thing here, Finbert, okay? Pre-trained model for financial text analysis, something that is this, it is dedicated data set and type of data that is being trained on to analyze and to be able to recognize financial text. So that is the kind of second option there. And then the last option to use GPT-2 here, okay? LLM that generates contextually relevant text. Now, why GPT-2? Well, simple reason, it's free. It's reasonable to take that as an example of from the the class of GPT type technologies. Now, you could argue, well, isn't it a bit old? Granted. However, consider this, that it is still used widely today. It's still relevant, I think. It's free. It's small enough to be able to execute and run yourself. You didn't get it from Hugging Face. And therefore, although a lot of the current commercial LLM vendors are adding bells and whistles and all sorts of new capabilities to their technologies and their products and their offerings, understood, it still costs money, right? You still need to pay them in terms of usage or monthly billing or whatever mechanism there is. And so taking something a little bit simpler seems to me to be reasonable. And we'll take a look at that, okay? So let me show you a little bit more here in terms of the work that we previously did. So you recall I mentioned that we did something similar a while back. Okay, so this is just SingleStore's GitHub repo. Okay, so that's github.com/SingleStore-labs. Just look for the webinar code examples directory. And in there, you'll see something that we did previously, this fraud detection, okay, which is using scikit-learn, logistic regression, and Apache Spark and OpenAI. And so surprisingly, the work that Amit did was very similar. He was looking at a lot of the measures that I was doing, and this was last year and earlier this year, looking for accuracy, precision, recall, F1 score, to kind of evaluate these technologies and to see how they performed against this particular very specialist kind of data set. Lots of text, as I said before, based on financial filings, which you would think that something like GPT would do well on, okay? Because that's what it's designed for, to deal with something like text. And equally Finbert. Okay, so let me just switch to this now, all right? So this is the environment that I have. So with the link that you follow in, if you've signed up, or if you have an account already and you've logged in, it will look something like this, okay? So all I've done is I'll show you a couple of things, okay? And then we'll go through the notebooks one by one quickly. Group here, okay, on the left-hand side. And I think there is a move afoot to provide something called stage under the starter workspace, but I've just gone for the standard one here, okay? Call it whatever you want. Okay, this one is just taking a default here because I share this environment with other colleagues, so that's the kind of the next available. I could change that if I wished. You can choose your cloud provider. You can choose your region. Okay, so you've got quite a big choice there. And there's a couple of options there, which you'll see because I'm an employee that are unique to me. Let me just disable that. And then just down at the bottom, say next. Okay, so we'll do that. And then again here, you can choose the workspace name here. Okay, instead of workspace one, just call it whatever you want. This size is perfectly fine, S00. That will burn through, I think in this particular region, 0.25 credits per hour. So you recall that you get $600 worth of credits if you are signing up from scratch. In case you're wondering how long did that last, well, I've been at the company almost 3 years now, and I've still got credits from the time I signed up around about the time I joined. And in those days, they were giving out $500 worth of credits, okay? So it's 2 virtual CPUs, 16 gigabytes of RAM, perfectly fine. I've already got this running, okay? So I'll skip this, but all you need to do then is just say create workspace, okay? And that will create that for you. It takes a couple of minutes to provision. Okay, let me just go back here and I'll show you what I have running. Okay, so here is my workspace, as you can see. Okay. You don't really need any of the connection details because you'll be running this entirely within this environment. Now, I do have a database created, okay, but I'll show you how to do that in a moment. And then one of the things that you'll see on the left-hand side here, so here's my group. This is the workspace that I currently have. It says you've got one, and if I click on this, you'll see that indeed it says I've got something called fraud detection demo. Under databases, obviously, I've created something. So again, if I expand that, it will show me the database that I have, which is, again, fraud detection demo here. And then this last thing here, stage, I mentioned that a few moments ago, very useful. So let me click on that. And you'll see here that this is the space that you can use to upload the CSV file. And my bad. Okay, so it's 208 megabytes for this data set. Okay, so this is the data set that we looked at Kaggle. The zip file, unpack it. It's called final_dataset.csv. You just need to upload it. Okay, it takes a few moments to do that. And once it's there, we can access that data set without having to go outside this environment. So the data set, and again, you've got quite a little space there. It can take up to a 5 gigabyte file, which is huge. But I haven't used anything that large, but this is absolutely fine. Okay. And then from the left nav, again, if you look at notebooks there, okay, if I click on this, you'll see that you can create a new notebook. Okay, if we look at this pull down, you have two options here, new notebook or import from file, okay? So the links that Yukti will share with you for the GitHub repo, you just say import from file, okay? And then you can bring those notebooks in one by one into this environment. And so let's take a look at the first one, okay? There we go. So this is the first one, okay? So what we need to do then is to take the data. This is the data loader, okay? So all we're simply doing here is we are going to and make sure that you are connected here to the correct workspace for that stage, okay? Otherwise, this is not going to work. We're just simply going to read that data set in here, okay, from stage. We can take a look at it, and you can see it's sort of a little bit compressed there. So this line here, what Ahmed has called fillings, I didn't like the name, so I changed it to filings, which I think what he meant, and whether it's fraudulent or not. So essentially, you've got a huge amount of text being stored here, and that's what we're taking in and what we're going to analyze. So quick bit of column manipulation there, just changing the column name, calling it filings rather than fillings. And then what we do is we create our database here. Okay, fraud detection demo. We've got a table, which we're going to use long text, okay, because it's a fair bit of text that can store multiple gigabytes worth of data. The fraud itself is just yes or no. And that's all we're doing. We're just loading that in. This next part then is to take that data frame and simply store it into the database. Now, the reason for storing it in the database rather than working on the CSV file directly is because in the near future, I plan to do some additional work with this data set. So either as a blog post or perhaps we'll do another webinar where we're going to utilize some more of SingleStore's capabilities to do analysis of that data, maybe in the fraud domain or perhaps related. But that's the reason for that. And it makes it like a little bit easier as well, because once it's in the database, it's under control. You've got consistency, isolation, durability, all of those nice features that you get. You can also work with other colleagues on that data set as well, and they don't have to keep loading in from the data frame. So essentially, we mentioned that it's two lots of 85, which is 170 rows. And then once it's in, just as a sanity check, pull back 10 rows there just to check that we actually have that correctly in, and we do indeed. So we've got the fraud and the filings. Okay, so that's all we're doing there. Simply a bit of prep work to load that in. Next step then, let me just keep an eye on the time, okay, so we make sure we're running well to time. We've got this first part then in terms of the logistic regression. Okay, so each notebook has got a TLDR, if you don't want to read the summary, but essentially it just describes what we're going to do there. And then the summary contains a bit more information in terms of what's going to be processed. So again, we're going to use scikit-learn, and we're going to do a bit of plotting. Okay, so going to look at the results, create the confusion matrix as well to see how well did we do. Standard sort of import of libraries here. You can see we're going to use SQL Alchemy. We'll connect to the database again here. And again, a little bit of information there. Action required. Okay, so make sure that this is properly set up. You're pointing to the database and the workspace that you want to use. And then we're simply reading that in. Okay, and then after that, just train test split, pardon me. And then we're using this TF IDF, working through that. And then that is actually fairly fast. Looking at the accuracy, getting the validation accuracy, the precision, the recall, the F1. So it's actually not bad. If you look at those numbers, those are actually quite reasonable, given that there's not really much tuning again done there. And then if we simply plot this to see how well did we do, you can see here that overall, in terms of identification of the The true label here on the left-hand side, if we take a look at the fraudulent cases, well, standard, just, logistic regression without much effort in terms of implementation, you can see it's actually done pretty well. So of the 17 cases there, 16 have been identified correctly. Only one has been misclassified here. Okay, so it was actually a fraud, okay, the true label, but it was marked as not a fraud. So that's rather more serious than the other case. And if we look at the non-fraudulent, okay, we can see that 11, okay, it's correct. And then this one here, 6 have been misclassified. So we're probably going to upset a few customers through this mechanism. But again, you can see that the numbers are fairly small there. The key thing about this is that it ran very fast. I was able to run the code extremely quickly and get this back. And what I could do now is go back, iterate, and see what improvements I could make to get better results back, or maybe take a larger number of test cases, for example, so on. I mean, this makes it very iterative and super easy to use. Very nice to be able to do that in real time, okay? I don't have to sit around for hours and hours waiting for this to evaluate. And then again, if we look at here, we can see that this is done pretty good. So the area here, 0.88, so that's getting, that's better than a 50-50 sort of case. And overall, that's not bad. That's for this kind of initial evaluation. So we've done pretty well there. And you can see the precision recall curve there as well. So, thumbs up for logistic regression there without too much effort, without too much compute resources or too much time. It's been able to build a pretty good model there and be able to evaluate that for us very, very quickly. Okay. How about the next case then? What happens with Finbert? How would we do here? Finbert, again, TLDR summary there. Okay, now I'll explain why it's not a good idea doing this in real time in a moment. You'll get to see this. So here, we've got to put a lot more effort into this, okay? So again, we import the libraries, and we're going to use Torch and transformers here. Again, we connect to the database, get the data set read in, and we do a bit of encoding there and tokenization. Okay, don't worry about this. It's simply because I saved this, and when you run it, everything will display correctly. It's just some graphics that I'm not showing there. The actual result there is available. So this is actually using something Finbert-pretrain. This is specifically designed on this sort of financial data, and I believe this is the author, Yi Yang, from what looks like the Hong Kong University of Science and Technology. So I'm sure the research work is available again if you want to drill deeper into that. So again, train, validation, test sets, very fast to do that. We then work through this using this, validation data set, test data set, load the pre-trained BERT model for sequence classification, okay, which is the from Yi Yang. Don't worry about these. Again, it's just warnings. And then this training loop. And this training loop takes approximately 14 minutes to run, okay? 3 epochs. Takes a little bit of time to get through. And then the evaluation phase, that's pretty fast. And the metrics for the test set, again, accuracy, not very good, unfortunately, disappointing. And the area under the curve is only a bit better than flipping a coin, 50%. So we're not really doing very well there. And you can see here, this took 22 minutes to execute this part here. So you can see I ran this a little bit earlier today. So fair bit of time in terms of running through this. But over time, the accuracy here, does get better. You can see, improves. Okay, finally we get something a bit more reasonable. And again, if we plot this, we can see that, well, it did pretty well. So for the non-fraudulent data, the true label and the predicted label, all 14 cases there. We didn't get any misclassifications here. However, For the fraudulent cases, you can see, and it's only given us 2 here. Okay, lots of misclassifications there, not very good. And as I said before here, overall, if you take a look at that, that is like no, but just slightly better than flipping a coin, right? 50-50. You're not really getting much in terms of the overall benefit of that. So kind of disappointing. Something that is specifically designed around the, analysis of this sort of financial data. I'm not sure what the issue is. I wonder if it may be the batch size. Originally they were set to much higher values. I had to reduce it simply because of memory exhaustion. You can already see up here, for example, that I'm using up nearly 11 gig of the 14 gig memory available. So I had to tune it down a bit in terms of running it. But ultimately, I would hope it doesn't make a difference. Okay. You're welcome to do a bit of tuning yourself and test this out. So overall, kind of, not exactly a thumb up, not exactly a thumb down, kind of in the middle. Bit disappointing though. And then finally, if we look at GPT as an example, again, this has potential, as we talked about. Similar sort of setup here. We, again, take the data, we encode the labels, we use this GPT-2 tokenizer, okay? And there's a bunch of stuff we have to do in order to get the data into the format so that we can use it properly. So fair bit of work, as you can see, in just doing that. And then compare this to the first solution that we had. There's, again, more work required here. So again, I had to reduce the batch size here, okay, from the large number that originally it was. I think it was like 32 or something like that, down to about 4, so that it didn't exhaust the memory resources, would actually run to completion. The training loop here took a fair bit of time. Again, this took 23 minutes to complete in this environment. Okay, so needs a fair bit of time. But over that period of time, training loss is improving, doing better. Okay, and then ultimately, the proof of the pudding is in the eating. We take a look at the accuracy and the F1 score and so on. And again, not very good end result. And if we plot this using the same sort of mechanism here, you can see, again, sort of a mixed bag there. So it's done reasonably well here. Fraudulent. 4 misclassifications. Okay, so it's better than the Finbert. And here, not so good. I mean, it's, again, sort of roughly half and half in terms of the overall result there. And there we can see, again, very similar, little bit better than sort of flipping a coin, 50, 60, 40. So, what can I say? So my assessment, again, I tried to give it the benefit of the doubt in this particular case. And so my thinking is that, having gone through this process twice now, once where I was really trying to deal with credit card data. And again, let me just take a look at this. Okay, so there in the previous case, we were pushing the technology a little bit to look at this transactional data and say, okay, analyze this. I'm going to tell you whether it's fraudulent or not, build a model, and then I'm going to give you some new data that you haven't seen before. Tell me what you think it is, whether it's fraudulent or not, based upon this. And, the GPT didn't come out very well overall. I think the results were skewed one way versus the other. So I think it got either the fraudulent or the non-fraudulent good, and then the other one, it didn't do so good. And then for this particular case, as you saw, we've now given it something which is more up its road, its street, in terms of the kind of thing that it should be able to analyze and should be able to do well at. And again, you see a very mixed bag in terms of the results that we've had back. Okay, so what do I think? Summary. Well, model complexity. So Finbert GPT-2 offer higher performance in text classification than logistic regression, but need more computational resources. As you saw there, needs more time Much more care and attention, maybe more tuning as well, just that you don't exhaust the resources when you're actually running these tests. Data preprocessing, effective tokenization, and handling padding are crucial for transformer models. Again, that requires some expertise and knowledge, which not everybody has got. So you either hire a data scientist or you need to learn and go away and figure out, what are the things that you need to do in order to ensure that these things run properly. Evaluation metrics, you saw there was a variety of things that we looked at: precision, recall, F1 score, the area under the curve as well. That gives you much more of a sort of an insight versus just the accuracy. So a lesson learned there is that take a variety of these metrics into consideration and then don't just look at one number. That's not a good idea. There's a plethora of things that may be important, and you may be able to go back and tune it in one way or another way in order to improve the results. Visualization, as you saw, very important. The picture is worth 1,000 words. Those the confusion matrix and the charts that we saw, immediately we can see how well it's performing or not. And that is very, very useful. Okay, so my overall assessment, GPT-2 gets a thumbs down as far as I'm concerned. So I'm yet to be convinced that this GPT LLM technology can really help. As of today, I think I'm still waiting to hear of an example where it's been applied. I think there are cases where it's complementary. Certainly, it's good at analyzing text. It's great for the RAG stuff. It may be very useful for analyzing fraudulent emails, for example, or documents or things like that, but it hasn't done so well in this particular case. Now, my advice to you, take what I've done, by all means, customize it and take a look at it and have a look at Amit's work. Okay, so if we go down to the bottom, let me find, oops, pardon me, let me just find the right notebook. Okay, you'll see that he is on GitHub. Okay, so I've added the MIT license here, so you can see the link here to his work on GitHub, which contains far more than I've had time to cover today. It's open source under the MIT license. By all means, take a look at his thesis as well, which is published in the PDF file there. It's got a lot more information. I had a quick read of it. I think my results are significantly different from his. I'm not sure why. Maybe the environment, perhaps my coding in terms of what I've taken from him. Maybe I've done something, might not be quite right. It's something I need to investigate. You're welcome to take this and try it for yourselves as well. Okay, so let's now, okay, so my quote that I always like to say: any sufficiently advanced technology is indistinguishable from magic. I'm looking forward to the day when something like an LLM will be able to do the fraud detection magically for me, and I don't have to create these models, don't have to do all these advanced things. With the pace that this technology is and the rapid changes it's going through and how fast it's moving, how cost effective it's becoming, the fact that we have these great open source models as well, which are sometimes as good, if not better, than the commercial offerings, I think this is only a good thing. And I think the future is going to be bright, as long as we don't run out of electricity to run all of this stuff and damage our environment. I mean, this is the issue. So already you saw in the couple of examples there for Finbert and the GPT-2 that it took a fair bit of compute time, and it was pushing the amount of memory that I had to tone it down a bit, simply adjust it so that it didn't exhaust the resources that I was using. Okay, there we go. So let me stop at this point then and take a look at the time. How are we doing? That for me, that's great. I've finished 10 minutes early. Okay, Yukti, over to you. And
Awesome.
questions, please. So let me
Okay.
stop the share there for a moment. Okay, and see what we can do in terms of questions. Anything super interesting that you think
All right.
that
I
will
mean,
stump me?
that was an amazing session, Akmal. That was so well demonstrated, like with all the graphs that you had.
I'm
Amazing.
really sorry I couldn't run this stuff. Like I said, I mean, it takes 20 plus minutes to run some of this code. So the notebooks are yours, okay? You're very welcome to test it out in our environment. If you have something more substantial in your environment, you've got GPUs, you've got tons of memory. By all means, run it and let me know what you're able to achieve. I'd love to hear if you're able to get some really good results using Finbert and GPT-2. I mean, I'm here to learn as well.
Yeah, guys, like we absolutely encourage you guys should just go and play around with the code. I've put it in the chat and like just, if you guys find something, actually just come to us and tell us as well because we're so curious about it, like what everyone finds. And so, guys, like we'll actually start in the best interest of time with the Q&A session. Just a reminder that the Q&A function is at the lower corner of your Zoom console, and just make sure you're logged in with your actual name and email address. And I'll just start with some questions. We actually have a lot of questions.
Okay.
So I'll just pick something for Akmal. And so one question we have from Sanket. He says, how do we get the notebooks? Like, is there a link we can go to?
Oh, did you share the GitHub repo link?
Yes, I did. I did.
You did, right. So that should be there. Let me go back here and let me share this again. Okay, and at the moment you're seeing my desktop and nothing else. One moment. Let me just give me a sec. Let me find, where are we? Bear with me. Okay, so it is github.com. Okay, and oh yes, for the one that I showed for the webinars, it's just SingleStore -labs. Okay, that's the one that you should be
Sounds good.
yeah, that one. Okay, and then for mine, it's just on my website. Okay, so my repo. So all right, there we go. Okay, that's not what we want. That was Olama from a couple of days ago. So if we go, wait a minute, where are we? Oh dear, I'm all fingers, sorry. It's one of the things of being late in the day and not having dinner yet. So there, let's try this. There we are. Okay, so this is the link. Okay, so github.com/veryfatboy. Okay, and if in case you're wondering, that's a joke between myself and my wife. So it's stuck over the years. So just go to repos and you'll see fraud detection. There we go. Okay, so you'll see all 4 notebooks there, the data loader. Okay, number 2 is the logistic regression. Number 3 is the Finbert. Okay, let's just try and get that. It doesn't like it. And then number 4 is the GPT-2. Okay, and so each of those notebooks, as I said before, there's a license at the end of 3 of them because, like I said, I've taken the code from Amit, his work, and therefore there's a link back to his repo. If you want to have a look at his stuff, by all means, go ahead. He's used simply Python files rather than the notebooks, Jupyter notebooks. I've just adapted that to this and used SingleStore for storage. Okay, sorry, Yukti, you were going to say something. Sorry to interrupt.
No worries. It's very clear. I think it's pretty straightforward, and like I hope it answers the question. And so we have one more question. What is the number of embeddings that usually work well in Finbert?
Oh, for Finbert, actually, we didn't use any embeddings, right? There's no, perhaps I'm misunderstanding the question. The key thing that I changed was simply the batch size. That was to try to keep it within the resources here. So you can see here, batch size is set to 4, which is fairly small. But if I think it's a higher value, it will evaluate it faster, okay? Because it kind of do it in parallel, yeah? But it will consume far more memory than is available in this environment. And you can see here that I'm pushing it at 10.63, which is, and a little bit of slack there, a little bit of room to maneuver there, but not much. You're welcome to change that value to higher. So you could try 8, for example, is the batch size. That might work. I do remember taking the defaults and it would not run. So, but if you have access to your own environment, you could try it within there. If you've got plenty of memory, storage, compute power, by all means, adjust it to whatever is suitable for you. That's my recommendation.
Uh, all right, that was, I think that answers the question, and we can move on to another question. So, we have a question from Salim. He says, how do you transform the input data for logistic regression?
I think here, if we go back here, you'll see the code itself. Let me just try and pick this one. So it's a very, very straightforward process. Okay, train test split. So this is just using scikit-learn. Okay, standard scikit-learn, standard techniques, and we are just using this. Let me just try and do. There we are. Okay, logistic regression. And then here you'll be able to, I mean, my recommendation is just look through the code. Easiest thing to do. Label encoder, okay. And then this is using here, okay, this vectorizer, TF-IDF.
All right.
Other than that, we are not actually, I mean, generally when we do a lot of these webinars, we do generate vector embeddings. In this case, no, it's kind of a different approach. Essentially, in this example, this webinar, we're just using the database system, SingleStore, just for storage and nothing else. It's not really doing any processing for us. Like I said, the reason I wanted to do that is because I have in mind some other things that I'd like to try and do on that data, which actually makes full use of SingleStore's capabilities, as well as other things that we might want to test out to see if we can get, some other algorithms or other techniques to on that data in terms of delivering better results on the fraud data. So the rest of this is very straightforward. It's yeah,
All
test set
right.
and so on. Yeah.
Uh, I think the question is answered, right?
Hopefully, if not,
Yeah,
just drop us an
it's
email.
pretty straightforward.
Yeah, yeah,
Okay, so moving on to the next question, then we'll get to the raffle winner.
yeah,
So we have a question from Shruti. She
yeah.
says that can you discuss the advantage of using inbuilt notebooks over something that's external to the portal or locally installed?
Right. So the benefit, that's a great question, Shruti. Thanks very much. So there was a time when I think within that first year and a bit that I was with SingleStore, where essentially the company did not offer this built-in notebook environment. And therefore, I typically had to go outside. Deep Note was one of the places that I went to run my notebook, simply because in those days, they used to provide lots of great free resources. It's much more constrained now. So in terms of how much storage and how many notebooks you can create in Deep Note. But during that sort of time from then to now, SingleStore has integrated this notebook feature into the portal now. So now I have a single environment, which is great for me as a developer. Now what it means is, again, I don't need to install anything. I just ensure that I've got some compute resources, create a workspace. The notebook environment is built in. You saw me showing you how you could upload the data, CSV file, that will be retained there. And then again, I can run this in this portal. I can connect to my database. I can access the data, read and write, perform queries. And there's other nice things as well that I have available to me. For example, a SQL editor, for example. There's other tools as well, like Visual Explain and so on. So this is a kind of a single environment which you can use without having to worry about using some external install of Jupyter, for example. For those that attended on Monday, you'll know that I used a very difficult, virtual machine environment in terms of very sluggish and terribly poor in performance, but it worked. Okay, we used Olama, and the point I was trying to show there was that I have a firewall. My laptop is my environment. That's my development environment. Everything is learning locally here. I don't have to go outside that environment. So that's the point I was trying to prove. But here, again, you have firewall control as well. Okay, if you go to the top right, okay, you can stop the bad guys here. Okay, so here we are, edit firewall, for example. You can change the rules. And there's a separate firewall for the workspace as well. So essentially, you can keep the bad guys out. You do all your work in one environment, and that's all you need. Just have a web browser and an internet connection, and you can do stuff anyway.
All right. Okay, so in the best interest of time, we're already on the top of the hour. So, guys, I've actually noted that you guys need some help in finding some links related to GitHub link to Amit's repo and the Kaggle dataset link. We'll share it in the email that's going to come to you after this webinar, and
Yeah.
it's be a follow-up email. And anyone who registers it will also receive it. So, don't worry about it. I'll make sure to include everything. And
Yeah, you'll see immediately after we finish here, which I think we're over time already.
yeah,
I
yeah,
will
yeah,
send you those
absolutely.
links, okay? So you can include those in the
Yeah,
follow-up
I'll
email.
remind you. Don't worry about
Okay.
it.
All
All right.
right.
So,
Thank you.
all right. So in the best interest of time, let me just
Let's
come to
do
the
the draw.
quote. And Akmal, you can share your screen. So, guys, we have our raffle winner announcement coming up. So before that, I just want to remind you guys about the. Can you go to the previous slide, please? Yeah, thank you. So we have got amazing sessions coming up. Please tune in on May 29th. That's Supercharge your MySQL apps. At scale, no code changes. We have a similar webinar happening tomorrow in IST time zone. So please feel free to connect with the team and you can register. And on June 3, we have using open source Copilot for personalized banking applications. And on June 5, we have building full stack AI apps with Versal Next.js GPT 4.0. If any of these topics sound interesting to you, please RSVP right now. And I hope to see you all there. So the announcement that you guys have been waiting for today's raffle winner, it goes to Larry Bortner, who's a managing director of insights and decision analytics at Morgan Stanley.
Oh,
Congratulations, sir, and thank
congratulations,
you
Larry.
so much for joining. Guys, if this is not you, please do not give up. We are going to announce one more AirPods winner and Meta Ray-Bans winner by the end of the day for anyone who has tried out today's demo, along with Akmal. And you guys will be eligible and be entered to win. Thank you so much, Akmal, for this amazing